I welcome you all in this session. Today we are going to construct DFA. We have to construct a DFA that accepts set of all string over A and B of length at least 2. In the previous session, we had constructed a DFA that accepts set of all string over A and B of length exactly 2. Here we are going to construct a DFA that will accept set of all string over A and B of length 2 or more. So first we have to find the sigma, that is A and B, and the language L will be infinite because the strings of length 2 are AA, AB, BA, BB, and the strings of length more than 2 will be infinite. So the language becomes infinite. Now, in order to construct a DFA, first we should try to draw a skeleton of this state diagram using first input string, that is AA. Means first we are going to make a DFA that will accept our first string. So we are trying to construct a DFA. We have taken initial state A, an intermediate state B, and a final state C. We are taking first input string, that is AA. So we will check for it. From initial state A, on input small a, the next state will be B. From state B, on input small a, the next state will be C, and C is a final state. So our first input string is going to be accepted. Now we will check for the second input string, that is AB. From state A, on input small a, the next state will be B. From state B, on input small b, the next state will be C, and C is a final state. So the second string is also accepted. Now we will check for the third one, that is BA. From initial state A, on input string B, the next state will be B. From state B, on input small a, the next state will be C, and C is the final state. So our third string is accepted. Now we'll check for the fourth string, that is BB. From initial state A, on input small b, the next state will be B. From state B, on input small b, the next state will be C, and C is a final state. So our fourth string is also accepted. So we have constructed a DFA that is accepting all the strings of length 2. But what about the strings of length more than 2? In order to construct a DFA that will accept strings of length more than 2, we have to add one more transition like this. Now we will check for the fifth input string of length 3, that is AAA. So from initial state A, on input small a, the next state will be B. From state B, on input small a, the next state will be C. From state C, on input small a, the next state will be C, and C is a final state. So now this DFA will accept all the strings of length exactly 2 or more than 2. So this is the final DFA. Now we can conclude that, as stated in the previous session, a string is accepted by a DFA if and only if the DFA starting at the initial state ends in an accepting state after reading the string, and a language is said to be accepted by a finite automata if all the string in the language are accepted by the finite automata, as well as all the strings which are not in the language are rejected. We can cross check this DFA. We had constructed a DFA that will accept the strings of length exactly 2 and more than 2. That means this DFA should not accept the strings of length less than 2, that is 1, or empty string. So we will check for the string of length 1. Suppose we have a input string A, that is of length 1. So from initial state A, on input small a, the next state will be B, and B is not a final state. So this DFA will not accept the strings of length less than 2. So this DFA is accepting all the strings that are in the language, and it is rejecting all the strings that are not in the language. So this will be the final DFA. So this is all from my side for this session. Thank you for joining.